Channel Notebook Maths. Today I am going to solve here important topic. Based on this we are going to solve some important questions for board exams. These are very important repeated questions for in exam children. So watch complete video. Chapter is matrices and determinant chapter. Okay, one by one I am going to solve here in this video. Watch complete video. Okay, first one is find the character roots. Four important questions I have written in this video. So different types of questions I have written here. First one is find the characteristic roots of the matrix. Find the eigenvalues of the matrix. Find the inverse of A using Cayley-Hamilton theorem. Very important theorem. Okay, based on this we have to find the inverse of given A matrix. Okay, if A is given, find A power 6 using Cayley-Hamilton theorem. Okay, these are important questions I have written here. So watch complete video. Very important for every student. Matrices chapter. Finding characteristic roots, eigenvalues, inverse and A power values. Okay, using Cayley-Hamilton theorem. Okay, please watch complete video. First question is find the characteristic roots of the matrix. Okay, given matrix, first solution. Okay, let's start the solution, children. First, given matrix we have to write. Very important for exams. So please watch carefully. Given matrix I am taking as 1 3 A matrix, that is 1 3 4 2. Okay, what is given here question? Find the characteristic roots. How to find the characteristic roots? Characteristic roots equation is what? The characteristic equation, sorry, here now it's clear. Okay, characteristic equation for the given matrix we have to find A minus lambda I equal to 0. Okay, for any questions if we asked to find the character equation, then we have to find A minus lambda equal to 0. So this is very important to remember for exams. So I am highlighted in box. Please remember this formula. A minus lambda equal to 0. Here lambda equal to 1, I equal to, I is identity matrix, that is 1 0 0 1. Okay, here A is given. Substitute the values in the given. Here characteristic equation is there. In this we have to substitute the value of A and lambda. We have to find the lambda values. So lambda into I means 1 0 0 1 identity matrix, that is. Now we have to subtract the values 1 3 4 2. First we have to multiply this lambda 0 0 lambda. After multiplication we have to subtract this 1 minus lambda we get here, and 3 minus 0 3, 4 minus 0 is 4, 2 minus lambda here we get here. So now we have to find the determinant of the given here. What is the det of A is what? We have AD minus BC form. So always when we have to find a square matrix determinant, we have to do AD minus BC. Okay, A, B, C, D is the values. AD means this one, A into this one, BC means this one, we have to multiply. Now 1 minus lambda into 2 minus lambda minus 3 into 4, okay, equal to 0. From this we have to find lambda values. Okay, so very important problems for inter, B and degree, and in PG also matrices chapter. So please watch video. 1 2s are 2, 1 minus lambda, 2 lambda, minus into minus plus, we have to multiply these two terms. Minus into minus plus, lambda into lambda, lambda square. Minus 12 we get here. Okay, now find the lambda values from here. That is lambda square here. Here lambda minus 3 lambda. Minus 12 plus 10 is minus 10 equal to 0. Okay, now we have to factorize this one to get the lambda values. From this we have 10 is there, 10 ones are 10. When we multiply, when we add or subtract, we get 3 here, and multiply we get 10. Okay, which values we get? 5 lambda plus 2 lambda. See here, factorization, 5 2s are 10, 5 minus 2 minus 3 we will get. So this is the perfect factorization. Take lambda common here, lambda 5, 2 common, lambda minus 5 remaining in this step. Okay, now take out lambda minus 5, lambda minus 5, 2 common here, take out lambda minus 5. Remaining term is lambda plus 2 equal to 0. So lambda values is lambda minus 5 equal to 0, lambda plus 2 equal to 0. Okay, now lambda equal to 5 comma minus 2 values. So the what we have to find from the question? Find the characteristic roots of the matrix. So these are the, therefore we have to write at the end of the solution, what we have to write? Characteristic roots are 5 comma minus 2. So this is the solution. Like this we have to solve matrix whenever given. We have to find the characteristic roots. Here find the eigenvalues of the matrix. Second question is, second one, solution. Given what? Find the eigenvalues. We have to find eigenvalues, children, for given question. Given a is equal to what? We have to take it as a 1 3 2 minus 4. 1 3 2 minus 4. I am taking it as a. Now solve this. Okay, how to find eigenvalues? Same like this only, we have to substitute in the using characteristic equation. We have to find the lambda values. That lambda is only the eigenvalues, children. Okay, characteristic roots also lambda and eigenvalues also lambda. So don't confuse in between two questions. If we have given characteristic roots or eigenvalues, same process we have to do here also. A minus lambda is the perfect formula for characteristic roots and eigenvalues. So I am using here same formula to find eigenvalues. So to find eigenvalues are, so take as by using characteristic equation. Okay, characteristic equation, we have what? A minus lambda I equal to 0. This implies A is how much? 1 2 3 2 minus 4. Substitute minus lambda into I means 1 0 0 1 equal to 0. We have to find the eigenvalues. Okay, now 1 minus lambda. Okay, 3 minus 0 here, 2 minus 0 2 minus 4 minus lambda equal to 0. Okay, now AD minus BC. 1 minus lambda into minus 4 minus lambda minus 3 into 2 6 equal to 0. Now multiply these two terms, we get lambda factorization. After factorization we get lambda values, that are the eigenvalues of the given matrix. So minus 4, 1 into minus lambda into minus plus lambda 4 lambda minus into minus plus again lambda square minus 6 equals 0. Here see the terms, lambda square is there, plus 4 lambda minus lambda plus 3 lambda minus 4 minus 6 is minus 10 equals 0. Okay, now factorize this, we get the values of lambda. So lambda square 10 is here, 5 lambda minus 2 lambda plus 5 lambda. 5 minus 2 we get 3, 5 2s are 10, we get 5 2s are we get 10. Okay, lambda common, lambda plus 5 minus minus 10 here 0, minus 2 common here, lambda plus 5 equal to 0. Now common lambda plus 5, take out common, lambda minus 2 remaining equal to 0. Now lambda plus 5 equal to 0 or lambda minus 2 equal 0. We get what? Lambda equal minus 5 comma 2. So what are the values of eigenvalues from this A given? Here eigenvalues are minus 5 comma 2. So same problem repeated but different way asked, that is find the characteristic roots of the matrix, find the eigenvalues of the matrix. Okay, same but in different way, but these two are different way to find. By using Cayley Hamilton theorem we have to find the inverse of a. Okay, third one, very important, but find the inverse. Okay, given is a is equal to what matrix is given. By using we have to, by using Cayley Hamilton theorem we have to find the inverse. Okay, how to solve this, very important children. Please watch complete video. Please do like, share and subscribe my channel for more videos from my channel. Please go and watch complete videos for board exams. Very useful videos are there, every chapter, every exercise I have uploaded. Integration, differentiation. Okay children, now find the inverse. Okay, using first we have to find the lambda values. How to find characteristic equation, that is a minus lambda I. Characteristic equation of a is a minus lambda I equal to 0. So substitute a minus lambda I is, a is 2, 2 3 2 5 minus lambda into 1 0 0 1. Again we have to do the same process in two problems we have done. So now we have to find the lambda values first in this process. Find inverse. So we have to find lambda values. Again 2 minus lambda 3, 2 minus 0, 5 minus lambda. Again AD minus BC we have to do 2 minus lambda into 5 minus lambda minus 3 2s are 6 equals 0. So again we have to factorize. 2 5s are 10 minus 2 lambda. Okay, minus 5 lambda we get here, minus into minus plus lambda square minus 6 equal to 0. Now we have to take out terms. Lambda square minus 7 lambda plus 10 minus 6 is plus 4 equal to 0 here. So factorize this term. So factorization we get lambda values. Okay, but we don't want lambda values here in this A inverse. To find A inverse, we don't have to find the lambda values. We have to find the this algebraic equation, that is lambda square minus lambda plus 4. So by using here, now we have to take a turn in this. By using question only given, by using Cayley Hamilton theorem we have to find A inverse. So Cayley Hamilton theorem. What is Cayley Hamilton theorem children? Every square matrix is satisfy its characteristic equation. So Cayley Hamilton theorem we have to write this, satisfy this equation means lambda square becomes a square, 7a I am writing 7 lambda as 7a plus 4 I am writing as 4i. Every factorization, every term we have to write as a and minus 7a plus 4 is constant, I am writing it as 4i. So in every problem we have to take it as in A form. Now to get A inverse, multiply with A inverse here. Multiply with A inverse. Okay, now this will become how much? A square plus 7a minus 7a plus 4i into A inverse equal to 0. We have to find A inverse. So a power 2 minus 1 is 1 minus 7, a power 1 minus 1 is 0 plus 4 into a into I means identity. What we will get? I into anything we get that value only. So A inverse equal to 0. A minus 7 I, here I 0 means I am writing a power 0 means I plus 4 A inverse equal to 0. Here what? 4A inverse equal to how much? We want value of A inverse, no? So 4A inverse equal to, this comes to outside 7i minus a. A inverse equal to how much? 1 by 4 into 7i minus A. Okay. Now here we know the value of A, that is matrix given from the question. Substitute here. I means 1001 is the identity matrix. So substitute here 1 by 4 into 7 into 1001 minus A is given question, that is 2325. Okay. 2325. Now we have to simplify this. Okay, 1 by 4 we have to find A inverse. No, 1 by 4 into what we have, 7 into 1001 here, and matrix 2325 is given. Okay, now 1 by 4 7007 minus 2325. Okay, now we have to what, we have to subtract this. 7 minus 2 is 4. 7 minus 2 is how much? 5. Okay. 0 minus 3 is minus 3. 0 minus 2 is minus 2. 7 minus 5 is 2. Okay. Now what we will get? 5 by 4. This 1 by 4 we are taking inside. 5 by 4 minus 3 by 4 minus 2 by 4, 2 by 4. After this we get cancel this 1 1 1 2 za, 1 1 za, 1 2 za. Okay, what will remain here? 5 by 4 minus 3 by 4 minus 1 by 2, 1 by 2. Okay, A inverse is the answer. This is what we have to find the matrix of A, that is A inverse. Therefore A inverse of the is inverse of A, inverse of matrix A. This is the solution. So like this we have to solve. Find the inverse of A means by using Cayley-Hamilton theorem if given in question. So using this theorem only we have to find the inverse of A. How to solve, children? First we have to find the characteristic equation. So this equation, this is the important question. So by using Cayley-Hamilton theorem we have to write this as A square minus 7A plus 4I equal to 0. Multiply by A inverse, we get the A inverse value. Now last question, very important. So I am writing here. Fourth question, children, watch complete video. If A equal to is given, find A power 6. That is given matrix is what? Given A equal to 2 1 minus 2 minus 1. 2 1 minus 2 minus 1 is given. Find A power 6. Okay, A power 6 we have to find by using Cayley-Hamilton theorem. Again we have to use this. Very important questions. Please watch complete video, like, share and subscribe channel for more updates on math topics for important in exams. Okay. Solution I am doing here, children. Again very important. So given what, children? Here given question is A equal to given. Very important and very easily to solve. Step by step I am solving here. Please watch carefully. Here we have to find again the characteristic equation. In matrix we have to perfectly find characteristic equation, lambda values. Okay, very important. Equation formula what is? A minus lambda equal to 0. So A is how much? 2 1 minus 2 minus 1 minus lambda into 1 0 0 1. Very common for this step, is very common in every problem. Okay, so 2 minus lambda 1 minus 2 0 minus 2 minus 1 minus lambda minus 1 minus lambda equal to 0. Here we get the characteristic equation and lambda values, but we don't want lambda values. Okay, only equation we have to find. 2 minus lambda into minus 1 minus lambda, that is AD minus BC. Cross multiplication, 1 into minus 2 and minus plus 2 equals 0. Multiply these terms, 2 into minus 1 minus 2, 2 lambda minus minus plus lambda minus in minus plus lambda square plus 2 equal to 0. From this we get equation lambda square minus this one is lambda minus 2 plus 2 get cancelled equal to 0. So by using characteristic equation, so by using before problem, that is we have converted in Cayley-Hamilton theorem, by using Cayley-Hamilton theorem, we have to write this theorem. We write this as a square minus a equal to 0. Okay, what we have to find? A power 6 we have to find. Okay, no, what we got here? A square minus a equal to 0. So from this we have to find what? A power 6. We don't have a power 6 term. So what we have to do? Cubing on both sides. If we want a power 4, we have to squaring on both sides. But here we have to find a power 6. Therefore we are cubing on both sides. Okay, what we will get? A square minus a whole cube equal to 0. That is a power 2 power 3 to 6 minus a cube equal to 0. Okay. Or we can write it as a square equal to a. So this one becomes a square whole power 6 equal to a whole cube. Okay, what we will get? A power 6 equal to a cube. Like this we have to do cubing on both sides. Okay, now it is perfect. A power 6. Okay, a cube. A square whole cube equal to a cube. That is we got here a power 6 equal to a cube. Now a power 6 equal to a cube we can write as a square into a. Okay, what we have already a square equal to a, no? From this we can write it as a square equal to a. So a and this one is a. So multiply a and a means we have the matrix that is 2, 1, minus 2, minus 1. Substitute here, we get a power 6. Okay, 2, 1, minus 2, minus 1. Very easy, but we have to use this trick, that is a square equal to a, no? Substitute the value of a here in place of a square. 2, 1, minus 2, minus 1. Now multiply. Multiplying this matrix, that is 2 2s are 4, 2 2s are minus 2. And here 2 1s are 2, 1 into minus 1, minus 1. Minus 2, minus 4, minus 1 into plus 2, minus 2. And here again minus 1 into minus 1, plus 1. What you will get? The final matrix is 4 minus 2 is 2, 2, and minus 4 plus 2 is 2, minus 2 plus 1 is 1. Here minus 2. Okay, smaller number is plus and bigger number is minus, so we have to write the bigger sign. So a power 6 is 2, 2 minus 2 minus 1. So this is the finally we got the answer, that is a power 6 equal to the matrix. So like this we have to find any matrix. If you are given any matrix and asked to find a square or a power 4 or a power 9, so first step we have to find the characteristic equation. By using Cayley-Hamilton theorem we have to convert and multiply the given matrix, given equation as that form, and we have to use the trick and substitute the values, and we get the value of a power what asked in question. Okay, so like this we have to do many problems from matrices. This is very important for degree students, pharmacy students, math students, and inter also. Very basic examples and important example repeated questions I have done in this video. Please watch complete video so that you can understand easily, and each and every step very important. Find the characteristic roots also very important, repeated in many step exams. Find the eigenvalues also very important, and the inverse of a also important, and find the matrix is given, find a power 6 using Cayley-Hamilton. This theorem is also very important. So 4 problems, and next video I will upload with next important questions. So please watch complete video. Thank you for watching. Like, share and subscribe my channel for more updates. Thank you. Bye bye.